This is example 3.6.10 from the book. In this problem, we're trying to differentiate the function y equals 4 minus 3x quantity to the 9th power. So in order to do this, we're going to need to use the chain rule. So we're going to need to break this function down into two component parts, f of u and g of x. Now we can see that this looks like some function raised to the 9th power. So our f of u is going to be u to the 9th. And our g of x is just going to be this inside function, 4 minus 3x. So we can verify that this is indeed the function that we're dealing with by taking f composed of g of x, and we're going to get back 4 minus 3x to the 9th. So this is our function. So now in order to use the chain rule, we're going to need to find f prime of g of x. So f prime of g of x. But before we can do that, we're going to need to know what f prime of u is. So f prime of u is just the derivative of u to the 9th, which is 9 u to the 8th. So now we can get that f prime of g of x is equal to, we're just going to substitute in g of x, which is 4 minus 3x for u. So 9, 4 minus 3x to the 8th. So now we have our f prime of g of x. We're going to need to get our g prime of x. And our g prime of x is simply the derivative of 4 minus 3x, which we can easily see is negative 3. So now that we have both of our parts that we needed, we can find that the derivative is equal to f prime of g of x, which is 9 times 4 minus 3x to the 8th times g prime of x, which is negative 3. And now we can just rewrite this a little nicer. Negative 27, 4 minus 3x to the 8th is equal to dy dx.